This paper describes a novel telerobotic search system using an unmanned aerial vehicle. The authors are Bingshen Lü, Jijie Wu, Yuzhong Cai, Wanqing Zhang, and Kuo-Shih from the Robotic Search Lab of the Mathematics Department at the National Central University. Let's move on to the experiments. Human experiment setup are as follows. The system consists of a joystick, a monitor, a 12-bit eye tracking controller, an Intel drone with a RealSense R200 RGBD camera, and a PS4 for downloading camera. The human controls the UAV via a joystick. The joystick inputs are velocity Vx and Vy, turn rate commands omega, and height h. The monitor displays streaming RGB images from the UAV. The gas tracker captures the human gas data. The computer on the UAV and the ground station exchange joystick commands, RGBD images, and robot positions. How to implement the experiment? First, to ensure the accuracy of the gas tracker, the human subjects rested their heads on a chin rest. Second, after both the subject and the UAV are ready, subject controls the UAV via a joystick and searches for a target in the shortest time. Third, when the human sees the target, the subject lands the UAV on the ground to complete the experiment. The experimental environment is a hallway and 2 rooms at Hongjing Building, National Central University. And the dimension of the experimental space is 20 by 20 square meters. In each map, the UAV starting location is at the blue point. The red points are the location of the victims, and the location of the victim is different for each experiment. The following are the experimental results. The figure below shows the search time from the experiment. 6 human subjects were recruited with different experience and flying drones, driving vehicles, and playing 3D games. For example, subject number 3 and number 5 have extensive experience, so their search time is better than others. How the performance of each subject. The 18 pictures are experimental results. Each picture represents a subject's UAV trajectories in a map. The column pictures represent the same subject's UAV trajectories in 3 maps. The row pictures represent the different subjects' UAV trajectories in the same map. Since map 3 is the most complicated of all maps, subjects need more time to explore the environment. For example, subject number 3, number 5, and number 6 Trajectories show that they try to explore the map. The search data is shown in Table 1. The parameters of human search experiments are shown in Table 3.